Hi everyone, I'm Dave, and I grew up with JavaScript, literally. JavaScript's like my little brother. I was going to say JavaScript's more like my little brother than my little brother, but that is being recorded, so I'm not saying that. So this whole presentation is in a system that I've been working on for presenting. And one day I'm going to do a presentation on the presentation system. But what you can do is if you go to that URL, view.nftra.in, view.nftrain, you can, in your browser or your mobile or whatever, you can follow along with the slides, and as I go through, it will synchronize as we go through. Particularly if you want to see something close up. So how many people in here do JavaScript on a daily basis? Okay. How many people are using Node on a daily basis? Fairly similar. So this is more of a high-level talk, just about where JavaScript comes from. And I had a lot of fun kind of preparing for this, and I got a bit, probably too deep into the history of it, and what makes it powerful, and some of the things that have led to confusion around it. So even if you do JavaScript every day, by looking a little further into the history and how it was put together, it can actually lead to a greater appreciation of the language and a way to use it. But in many ways, this talk will be gratuitously egotistical, because I've basically interwound my own story into the story of JavaScript, and I may have got carried away at points. It's basically more self-involved than a Facebook profile. And that's exactly what I look like with my shirt off.
Prove it.
Some other time. But it's all a bit of fun. It's not like I have a Russell Brand complex. It's not like I have a Messiah complex. So let's get into it. In 32 BD, which for those that don't know is 32 before Dave, which is 1953, a guy called John W. Backus gets fed up writing ASM. He was working on military systems for, I think, missile launchers for IBM. And he went to IBM with a proposal to reduce the amount of lines of code that you would have to write to make writing code easier. And that proposal was Fortran. Has anyone ever coded in Fortran before? Oh my goodness, maybe you should just come up and do the talk.
Too scared.
So this was 32 years before my time, but I did hear about it in my childhood. I ended up finding a book on it and flicking through it, but nothing really serious. The first Fortran compiler was released in 1957 and reduced the necessary statements versus assembly by a factor of 20. Fortran initially, yes, it was written, but it was also, the target was the punch card. And the punch card system that they used was very brittle, and for instance, if you dropped a box of punch cards, and they all got scattered and they went into a different order, now all the lines of your code are mixed up, and you have to kind of figure out how to put them back in order. So it was very brittle, and if they got damaged, you would have to re-punch the card, and computer time was very expensive, and that's why they used punch cards. So the whole, basically, continuous deployment, they weren't there with it yet. Long story short. So this is an example of some Fortran, when you put a C in the front, it makes it into a comment, and then that whole card would become a comment. Other than that, it's fairly straightforward what's going on. It's nice and easy to read, and of course it's all caps because computers at that time had partial ASCII, which was just which was basically just the capital letters and a couple of bits of punctuation and control characters. 27 before Dave, you're on the Davidian calendar, was 1958. And this is when two extremely important developments happened in terms of the history of JavaScript. Both Lisp and Algol were created in 1958. Has anyone heard of Algol? guys?
Never used it.
Has anyone heard of Lisp? More people have heard of Lisp than Algol. That's interesting. Because Algol is really the granddaddy of... Algol pretty much is in every language today. There's pieces of it. Whereas Lisp is in some languages, the more functional languages. Algol is like the daddy of imperative programming. So JavaScript has three main ancestors: Algol, Lisp, and Fortran. But Fortran is more like a step grandfather, which we'll look at later. So here's an example of some Algol, again all caps. You can see the colon equals, which was, I think, not exactly sure, but I know in Pascal that meant becomes equal to. And that kind of fed through and then got discarded somewhere along the way. Originally it was called the International Algebraic Language because and it stands for algorithmic language. That's what Algol stands for. So it was the best language designed by committee, according to one opinion, ever. It was designed by some really intelligent European and American computer scientists who got together for like a week or two and put this thing together. Lisp was the first language that was used for artificial intelligence programming. It's a highly functional language. And the amazing thing about Lisp is this concept of, let me see if I can pronounce this right, homo-iconicity. Apart from Miles, does anyone know what homo-iconicity is? Okay, so basically the data structure is the same as the programming syntax. And what that means is the interpreter doesn't have to actually create an abstract syntax tree from the code, because the code is already in the form of an abstract syntax tree. It just has to read it. And that's why there's so many parentheses in Lisp, because you have to be specific about your boundaries. There's no room for interpretation. Like, you know, when you do like 3 times 4 divided by 2, depending on where you put the brackets, and that changes which part is the expression that gets evaluated at what time. But it did get the nickname lots of irritating superfluous parentheses because of that. Something that's really cool about this as well, that kind of shows that it's an ancestor of JavaScript, is if you take this particular code snippet and you put it into a function, don't try and call the function because it will error, but it will pass correctly. That's legit JavaScript, which I think is kind of awesome. 1960 to 1970, there's a guy called Theodore Nelson. Has anyone heard of Theodore Nelson? Right, probably not. Because Theodore Nelson was amazing at visualizing the future and coining terms, but he never actually succeeded in building anything. He's still trying to build things, but he never actually got anything across the line for people to go, hey, this is really cool, let's work with this. But he did coin a lot of terms, and the term that he coined in 1960 was hypertext. That was the first time that word had ever been heard or written. In 1962, there's a creation of Simula. Anyone heard of Simula? It was the first object-oriented programming language, based on Lisp. Was it based on Lisp or Algo? We'll see that in a minute. I've got a diagram. But basically, it was for creating simulations. And prior to this, simulations had to be created by an algorithm that controlled the whole simulation end to end, and had to basically be like a god class, if you like, that interacted with elements individually and moved them and all that. What Simula did was it created this idea of encapsulation of a piece of logic into an object that could talk to other objects. And that was the first time that had been done. 1964 was the creation of the original BASIC language. I love BASIC. The first language I learned was BASIC. And what I really loved about it was it delivered on its promise. The B of BASIC is beginners. It really made it easy as a child to understand programming concepts. And one of the ways it did that was this rapid feedback that you got. You wrote a line of code, and you could run it, and you could see exactly what was happening, all on that blue screen that you get. And for me, JavaScript has that same property. You can open DevTools, you can try stuff out before you write any code, and that's actually still my preferred style. In 1965, two MIT computers start communicating with packet switching. On the 5th of August 1968, there was a public demo of packet switching. This was opposed to circuit switching. So prior to this, if a computer wanted to connect to another computer, it called the other computer up, just like you would call someone on the phone, and then you had a line connected directly to them. By introducing packet switching, they essentially virtualized that process and allow packets to go to any computer that's connected. 1969, the first successful message was sent over ARPANET. At 9:30, the first unsuccessful message was sent, and it crashed after the third character. And the first two characters were L and O. And I wish that the first message sent over the internet was "lol, here comes the interwebs," but it was actually logging. But it would have been amazing if it was. 1970 to 1980, getting closer to the year of my birth. The 70s saw development of the actor model. I'm going to say, has anyone heard of the actor model? And Miles is going to put up his hand. Has anyone heard of the actor model? Yeah. Oh, another one. So again, this wasn't a programming language, but this was a concept that people were exploring about what they were calling actors being able to independently communicate messages to each other concurrently in an asynchronous way. Which sounds to me a lot like microservices, to be honest. But it's also kind of influential on the way that JavaScript works. In 71 to 72-ish, C was created. 72 to, no, that's not right. Forget what I said that. 72 to 80 was the development of Smalltalk. Smalltalk was built on Simula. And it turned out to have some really powerful paradigms. And initially it was an educational tool, but it was actually very good as a production language as well. And there's still systems around today that have been built on Smalltalk. In 1974 was the first ever internet service provider called Telenet, which was a commercial version of ARPANET. And ARPANET was basically a military research program. In 1978, there was a blizzard in Chicago. It was called the Great Chicago Blizzard. And a couple of geeks got locked in and snowed into a basement, which, as we all know, is where everything, actually real stuff, gets built, in the basement. And they cobbled together, because they just have what they had to hand, they cobbled together the first BBS. I forget what it stands for, something bulletin system. What was it? Pardon?
Bulletin board system.
That's it, thanks. Just went out of my head. The bulletin board system. So they did that then, and in 1979, there was the first proprietary consumer online service. It wasn't the internet, it was a proprietary protocol, but it was close, it's getting close. And it was called The Source. And their tagline was, it's not hardware, it's not software, but it can take your personal computer anywhere in the world. So these concepts were kind of being driven forward. CompuServe in 1979 launched something called Micronet, which was a competitor to The Source, and they eventually bought The Source out. And then they in turn were eventually bought out by AOL, who kind of just disappeared in the last 10 years or something, didn't they? I'm sure they're still around, but who uses them? In 1982, the former bassist of the band Ocean Rock, you've probably not heard of this band, finds that most 8-bit adventure-style games are too verbose. He essentially believes that taking a subset of the good parts of a traditional adventure game will lead to an elegant and entertaining action game. He's right. After writing a medieval game originally called Night Soil, with a K, which was a joke about pooing the bed, Atari noticed the talent and they hired him. His name was Douglas Crockford. In 1982, Douglas Crockford wrote an 8-bit Atari game. And you can find the manual for the game online with a picture of Douglas Crockford looking really young. And it talks about how he plays the bass in the band, and how he's working on music with he's composing music with medieval undertones and stuff. But his approach back then was, there's too much, strip it down. And that's still his approach now, for those who know of Douglas Crockford. 1982 was an epic year as well, because it also saw the release of Danger Mouse. In 1985, the year of my birth, was the release of the Atari 65XE, which I later possessed about the age of 10. The first ever registered domain also happened in 1985, and it was by symbolics.com. Anyone heard of them? They were huge at the time. They were the creators of Lisp.
Lisp machines.
Lisp machines, yeah, right. They produced Lisp machines because Lisp was particularly heavy on the current architectures of computers, so they actually built specialized machines, which became redundant pretty quickly after the what's that law?
Moore's law.
Yeah, thanks. Moore's law kicked in. You guys should just come up here with me. Symbolics was also mentioned in Jurassic Park in the 90s as well, so they're quite well known. The National Science Foundation Network was launched also in that year, and they had 2,000 connected computers. Something else that happened in that year was HyperCard was created and released. Anyone heard of HyperCard? There's a lot of nostalgia, right? Anyone who's heard it, did they use it? Oh, shame. I would have loved to talk to someone who actually used it. So HyperCard was like the internet without the internet. They'd actually built a browser and not taken the next logical step of making that work across the internet protocol, which hadn't quite been invented yet, but it was getting there. Basically, you had a deck of cards, and you basically could define these cards, and the cards could have form elements and different things. And you could interact with those cards. And they also had this concept of hyperlinks. Anyone heard of hyperlinks? It was a hypercard with hypertext that had hyperlinks. And in 1986, they also introduced hypertalk. And if you read this, it's not far off from JavaScript or AppleScript either. On mouse down, answer file, please select text file to open. If it's empty, then exit mouse down, put it into a file path. And then, so it was one of the earlier attempts to create a scripting language that could interact with visual elements. Also in 1986 was the Self was designed. Anyone heard of Self? Oh yeah, Mars, have you heard of Self? Ah yeah. So Self was built on top of Smalltalk, and Self was Smalltalk without the classes. It was a deliberate move to take classes out of programming, and instead of classes they would have an object that would essentially point to another object. And when it pointed to another object, it was called its prototype object. Sound familiar? So, another thing that's, if you read the Self documentation, one of the first things it says is everything is an object, which is mostly true of JavaScript as well. Functions are objects. If you do type of null, it says object, which is a bug. If you do type of array, it says object. Even numbers and strings are objects, kind of mixed, and booleans are objects mixed with primitives. So I have a primitive, but when you access a property on that, behind the scenes it turns it into an object, and then calls that property on it as if it's an object. In 1987, CompuServe introduces the GIF format, and everything changed. I love it where his tail goes between his legs right there. When I was doing this, I just sat there watching it for 30 seconds, just going, it's hilarious. In 1987, I was watching Rainbow. And it's one of my earliest memories, but it was actually a really surreal experience because no one explains puppetry to a 2-year-old. I thought it was real, man. And I thought there was people out there like this. In 1989, TCP/IP becomes the global standard for interconnected networks. CERN, or Kern, don't know how to pronounce that, which was a nuclear research organization, had a big French name, opens its first TCP/IP ports so it can communicate with other networks that it's got going on. So this exposes its internal intranets to the world in a sense, but kind of privately as well. Also in 1989, Australian universities begin using IP protocols to unify their network infrastructure. Japan connects to NSFNet, and the first commercial dial-up access is launched. It's called world.std.com. You can go to that address today, and they still exist, and they still offer dial-up. They didn't really move on. It's funny how they were so forward-thinking, and then just stopped there. And I was all like, everything is awesome. That's how I was in 1989. In 1990, the architects, he's given a lot of credit for inventing the internet, but all of the pieces were already there. What he did, and he says this himself, is he was just like, I just was like, oh, you can put this with this and this with that, and you've got this system that can communicate. So he really pulled on the work of pretty much the last 60-ish years, because the concept of the internet was probably first talked about in a book in 1938, where it talked about a radio library that used televisions and different what was the other thing, and phone networks to communicate information. So like that concept was around from about 1938. For example, some of the things he did was he took SGML, which is Standardized Generalized Markup Language, and created HTML from it. He takes HTTP and the notion of hypertext and puts a protocol on top of TCP/IP and DNS and all of that kind of stuff. And to demonstrate these concepts that he's worked on, he starts creating something called the World Wide Web browser, which was later called Nexus. But it was limited to one platform, which was the BSD-flavored Next computers, as launched by Steve Jobs whenever he got kicked out of Apple, and then merged back into OS X. In 1991, the High Performance Computing and Communications Act supplies funding to the National Center for Supercomputing Applications. And that's significant because what they did with that money was build a web browser called Mosaic. Also in 1991, I got a Christmas present, and I was about 6. Honestly, at that time I found the choo-choo train more interesting, that I got as a Christmas present. But I had a babysitter, and I haven't seen him since I was 6, but he looked something like this. I'm not exaggerating, this is what he looked like. Maybe not quite exactly the same face, but had the dreadlocks, he was totally a stoner, and he was my babysitter. I called him Michael Blackhead, but that wasn't actually his name. I don't know why I called him that. So I kind of identify with JavaScript because both myself and JavaScript have colourful and somewhat obscure backgrounds. And this is what he showed me. In fact, I'm going to do it live because there's just something about doing it. If I can find my... Come on, where are you? Here we go. Just a second. Should have had this prepared. Cool. So this was, when you turned on the Commodore 64, the first thing you had was a command prompt. And that was amazing. That was an amazing thing. Because it made you interact with it on the level of, essentially, the level of a coder. And so he turned it on and he went, watch this. Print David, 20, go to 10, run. And I was astounded. Because the thing was, I just learned to write my name. And I was like, I'm not going to have to write my name ever again. And that's why my handwriting is terrible. In 1992, work begins on Mosaic, which is actually a multi-protocol client. It's not just an HTTP client, they support Gopher and FTP and different protocols at the time because they didn't know which one was going to win. So let's just support them all. And that's a good approach because not only were they multi-protocol, they were also multi-platform. So it worked on Unix, Windows, and Macintosh. And that is probably what led to the success of Mosaic or the influence of Mosaic, because it wasn't the first and it maybe wasn't even the best browser. What was going for it was the multi-platform capability, which even today is leveraged by us, because when we write a JavaScript web app, it's multi-platform, because we know it's going to run on browsers and on platforms, including mobile devices. The initial launch enabled the ability to inline images using the image tag. And Tim Berners-Lee did not like that. But they did it anyway, because they were like, hey, this would be really cool. And that was one of the things that made people love it. Because even though it was kind of crappy, they could at least put some visuals in that made it look kind of how they wanted to make it look. Because people love being about visuals. Like, you could be working on some awesome algorithm, right, that does some awesome thing, and you try and explain it to someone like, yeah. But you create something visual, like, I don't know, with WebGL, and they're like, whoa! And even programmers like that, but definitely like non-programmers won't. And so sometimes that leads to projects being done in weird ways. You know what I'm talking about? Yeah. You put on the polish before there's anything to polish. So this dynamic and what some would have called reckless approach of just doing whatever they wanted regardless of the spec, this doesn't sound familiar, does it? Led to some innovations. One of the innovations was the blink tag. So not everything that came out of that was good, but another thing that did come out of it that was good was the script tag. Because essentially none of that was in the spec. It was supposed to be a document format, not an application format. And that's why we use a document format to create web apps today. At the same time, there was something called the Urwise browser. The Urwise browser was written by some Finnish people. And all the code comments and all the documentation was written in Finnish. But it was the first browser to underline text links. And it was a really nice implementation. And Tim Berners-Lee tried to pick it up and tried to work with it, but he couldn't speak Finnish. So he would get to the point where he'd go, I can't work with this because I can't understand the documentation to do what I need to do. Also, in that year, I got me a Mega Drive. And whilst it was awesome, well, I love playing Sonic. Anyone else love Sonic? I love Sonic. Until I fell out with Sonic. Because at some point, there would be bugs in the game. And you'd be like at a crucial point, and something would happen, like it would freeze for a second or something, and you'd get killed. And in the mind of a 7-year-old, 6-year-old, whatever it was, that is cheating. It was cheating. So after it cheated me the 40th or 50th time, I threw it in a bowl of water and realized that's how water affects electrical items. But it's a crucial shift between generations. So I was fortunate to be at the end of the generation of the Commodore 64 and the Atari and the Spectrum and all of that, where you had an interface that you interacted with basically at a code level. Even if you wanted to play a game, you had to write a run tape. But when you started having these console games, it's purely about entertainment. You turn it on and you press start and you start playing. And again, that's gone up to the iPads. A lot of kids using iPads and just being consumers instead of creators. So my development was affected early on by this idea that you can create stuff like at a low level with computers instead of at a high level. In 1993, Mosaic was released to the public. Also in 1993, I changed stepdads because my current stepdad goes to jail because he's a drug dealer. And my new stepdad, he likes to go to boot fairs. So I'm up really early on the weekends going to boot fairs. And I get a couple of quid pocket money a week. And by this time, Ataris were not expensive at all. You could pick them up for a quid from a boot fair. So I ended up picking up a lot of these things. I had every single one of these and more. But that was my favorite one. For me, that was the most ergonomically comfortable Atari. These were okay. I think I had that one, but it didn't ever work. And that one was interesting because it had a cartridge, but I never found a cartridge that would work with it. And that one was interesting because, well, for one thing, it was the most embarrassing looking one. But you could play this game. You were supposed to attach a keyboard to it, but I didn't know that. So I was like, did you work this thing? And, but if you pressed a certain button combination, it would start a game, and you could play a game with the buttons, and it would shoot like a line, like this, and it would be a big line that would just shoot. It's kind of like a Space Invader style thing, except you're like a little cannon and you shoot things. And the enemies could fly into the line. And obviously at that time you're like, this is amazing graphics, 1993, Mosaic Resistance Republic, done that one. 1994, a new company is formed, and they're called Mosaic Communications Corporation. A couple of guys who worked on the Mosaic browser, including Mark Anderson, if anyone's heard of him, go and start this company. And the institution they came from was like, we're not happy about you calling yourselves Mosaic, that's our thing. So they renamed themselves to the Netscape Communications Corporation. They rewrite Mosaic from scratch, and they call it Mosaic Netscape, which is then renamed shortly after to Netscape Navigator. But the internal name had always been at Netscape for all the years that they were around. They always called it Mozilla. It was a portmanteau for Mosaic Killer, because their idea was to kill the old Mosaic browser and with a commercial browser. In that year as well, Spyglass purchased NCSA's Mosaic and also rewrote all the code from scratch. Because by this time, to support the three platforms, it pretty much had 3 code bases. So they wanted to create one shared code base. They purchased the rights to use the Mosaic name for millions of pounds. Personally, I now live in a house and it's got a basement. And as I said earlier, basements is where stuff gets done. So I have an old TV screen down there, and I have an Atari hooked up to it, and I have a basic programming book that I bought at a boot fair. And I start working through it. So I'm 9 years old, and I'm getting this education learning basic. Started the browser wars. Browser wars the first was in that year. December 1994, Netscape is born. And they declare it is free for non-commercial use. In 1995, Netscape say, wait, hold on, it's not free for non-commercial use. It's free for educational and non-profits. But everyone else has to pay. In that year, Brendan Ike, has anyone heard of Brendan Ike? Yeah. For various reasons. He started consulting with Netscape. And he designs JavaScript in, does anyone know how long it took him to design JavaScript? 10 days, yeah. See, talking to JavaScript developers, everyone knows these ones, and it's just like 10 days. You got it in 10 days. We all know it's only 10 days. In that year, 1995, I ruined my grandma's education. At this point, I'm living with my grandparents, and she has this old IBM PC. It's like a green screen PC with like some esoteric operating system I've never seen before. I'd seen DOS PCs and stuff before, but it wasn't DOS. It must have been Unix, I guess. And she'd been doing a college course using this PC. And there was this thing you could do with it. It had a drawing application where you basically drew in like big green blocks. And I would draw stuff with that and things. But anyway, I'm addicted to this machine. So like 2 or 3 hours a day after school, I'm going on this green screen computer. I don't think it was good for my eyes. And eventually, I managed to break it irreparably because this was how I learned stuff. I broke things, and then I was like, oh, that's how it works, you know. So my grandma loses all of her coursework and never finishes the course. But she replaces the IBM PC with a 386 machine with Windows 3.1. And the person that they got this machine from was an IT teacher, not at my school, some other school, called Mr. Bean. That was his name was Mr. Bean. I remember it clearly, for obvious reasons. But I would play around with this machine, and I would, every now and again, just completely break it and go, how do I fix this? And then Mr. Bean would come around and fix it for me. In 1995 as well, Internet Explorer is born. And they enter a license agreement with Spyglass, remember? Spyglass bought the rights for millions of dollars to use the name Mosaic, and didn't even use the source code. They enter a license agreement. So, Netscape's model is sell the browser to the public. Spyglass's model is license it to third-party vendors. So another of their customers was AOL. And the deal was, for every copy of Internet Explorer that Windows sells, they'll get a percentage, they'll get a royalty fee. Except Microsoft never did sell Internet Explorer, did they? They just bundled it with their operating system and said it was free. Spyglass later sued them for $8 million. 10 days. So this is the ingredients behind JavaScript. It's made up of scheme, which is where it gets its first class of functions from. Scheme is a descendant of Lisp. It's made up of self, which is where it gets its prototypal model from, and Java, which is where it gets its obligatory syntax. Because basically, what they wanted to do, or what Brandon wanted to do, was implement scheme in the browser, bringing some ideas of self into it. And it probably would have had a syntax that looks more like those languages. However, Netscape were basically in a very cozy relationship with Sun at the time, and Sun's flagship project was Java. So they were like, dude, you've got to make it look like Java, because we've got to keep these guys happy. So the Java syntax is not because it was an amazing idea, it's because of a political reason. And that's okay, but it has led to some issues which we may not have had, plenty of issues which we may not have had if it had been a different syntax. So here's a bigger diagram of the JavaScript heritage. So we come from Lisp, which leads into Scheme, which goes into JavaScript. Lisp also feeds into Smalltalk, and Algol feeds into Similar, which feeds into Smalltalk. And Smalltalk kind of inspired the Act model. And Smalltalk goes into self, goes into JavaScript. And then Algol goes into Pascal and CPL. Now CPL was the first language to use curly braces. That's where we get the curly braces from that ended up being in C, that ended up being in Java, that ended up being in JavaScript. On top of CPL led to BCPL, which led to B, and B was kind of a combination of BCPL and Fortran, and Pascal and B fed into C, and then C went to C++, which went to Java, which went to JavaScript. So it's kind of interesting to see all of the kind of languages that fed into the making of. So JavaScript in the early days was just like this toy language, and it's just been thrown together, but really it has a very rich heritage. So in 1996, things started to speed up. Netscape 2 and Netscape 3 were released in the same year, and with it JavaScript 1 and 1.1. Also in that year, IE3 was released with JScript. They could call it JavaScript because they would get sued, because Java was a trademark of Sun. It's now a trademark of Oracle. So they reverse engineered JavaScript, faithfully reproduced every single bug that existed in the language, and called it JScript. Later on, because they'd done that, when it came to standardizing the language, they insisted that those bugs remain in the language. So a lot of stuff could have been fixed early on had it not been for Microsoft's insistence that, no, this is how it should be. But there were bugs. By this point, the typical response to JavaScript was, JavaScript sucks. But, as someone pointed out later, JavaScript has sucky parts, and there is a difference. So why does it have sucky parts? Well, the first reason was they wanted it to be newbie friendly. So one of the decisions that was made for the friendliness to newcomers was implicit globals. E.g., when you don't declare your variable, it goes onto the global scope. So it tried to be like it tried to cover kind of syntactical mistakes and different things like that. But that turned out to be a really bad idea. Another reason was the Java syntax, because the Java syntax led to a lot of confusion. JavaScript is not a class-based language, and Java is. So to make it look like Java, you had to make it look like a class-based language. So then when people tried to use it like a class-based language, using new and this, and all those kind of things, they came up against all of these oddities and problems and unexpected behaviors because they're not used to like a dynamic runtime language that's prototypal in nature, behaving like it does. People creating big, massive hierarchies, and there's hardly any debugging tools for dealing with that sort of thing. So that's another reason why it sucked, and still sucks in some ways. The other reason it was rushed, just done in 10 days, and that's why type was not this object, because it was a rushed decision. In the end of 1996, Netscape submitted JavaScript to ECMA. In June 1997, EcmaScript 1 is released. ECMA was the European Computer Manufacturers Association, but they ended up being less about hardware and more about standardization. They called it EcmaScript because, as I said, Java is a trademark term, so they couldn't call it JavaScript. So they called it EcmaScript, and as someone said at the time, it sounds like a skin disease. It's probably one of the worst named languages, and that's why we still call it JavaScript. It was called ECMA 262. So version 1 was in 1997, and then version 2 was released in 1998. But version 2 was just minor alterations to help make it fit into an ISO format, so that it could be an ISO standard as well as an ECMA standard, and it still is an ISO standard. ES2 was implemented in IE4 and Netscape 4, as you can see here. One of the two hard things, what are the two hard things in computer science? Yeah, naming things and caption validation. The first name was clearly the name that it should have had. Mocha. Perfect. Short, kind of rolls off the tongue, you get a bit of a, in the back of your throat, mocha, but it's kind of a soft, so you can, kind of nice to say. It's a chocolatey drink, you know, feels good. And this was proposed by Mark Anderson. However, the marketing department came along and decided they wanted to call it LiveScript because that fit with their portfolio of marketing products at that time. And Brendan Knight put it like this: it made me throw up in the back of my throat. It was then renamed to JavaScript because of the pandering to some. And Microsoft called it JScript as a trademark issue, and eventually it was known as EcmaScript. At least they didn't, well, it could have been called ISOScript if they'd gone to ISO first. ISOScript, EcmaScript, ISOScript. ISOScript is nicer, I think. Only just. In 1997 to 1998, I was ringing up a phone bill of about £300 a month. Dial-up, when it first came out, when I was about 12, was actually really expensive. So my mum wasn't happy about that, obviously. She was a single parent too. So she was like, you need to do something about this. So I developed a strategy. And the strategy was, pick a website that I want to go onto, dial up, go to the website, and hang up. And I would do this and dial up for this action right here. This is HTML goodies. I don't know if anyone remembers the site or one on the site. Yes? Yes. Did you learn JavaScript from this site?
Maybe.
So it's by a guy called Joe Burns, PhD. It's still around, but it's got a new design. I got this from the Wayback Machine. It had a JavaScript section, and it taught you to write JavaScript. Really, really poor JavaScript. Globals everywhere and everything, but that's how it was, you know. So I would dial up, load a page, go offline, and then play with what was being spoken about, try my own examples, and kind of milk it for about an hour, and then dial up and hang up again. The only issue with that was the most expensive part of the phone call was the initial connection. And the thing was as well, is BT were terrible with their infrastructure. It took 4 or 5 attempts to dial up and actually get a connection. So you're probably spending maybe 50p 4 or 5 times to get the connection, and then it would have been a couple of pence per minute after that. I was also on, I don't know if I remember this, when I did this in London, no one remembered it apart from the lady to my left. Neopets, you remember Neopets? Come on, there's one person. Did you have, tell me this, did you have a Neopet?
It was below my 8th grade, I'm afraid.
I had 2 Neopets. But I think it was more popular among girls. I also played Worms 2 a lot around that period. 1998, Netscape open sources their code base and they call it Mozilla. And the tagline is "Free the Lizard," which is a innuendo. In 2000, I became more oriented towards the visual. I got a little bit fed up with the limitations of JavaScript, and I started using Delphi, Object Pascal, to create like Windows applications and stuff, just for playing around and stuff. And I also started using Flash and ActionScript, and I built a website in Flash and all that kind of stuff. And I played guitar. Also in the year 2000, IE 5.5 supported EcmaScript 3rd edition. So ES3, which is the one that we then used for like the next 10 to 12 years, added regular expressions, better string handling, what else? New control statements, try-catch, exception handling, which is a shame because try-catch is a fine idea, but it's another example of trying to place a paradigm that works better in a static compiled language than it does in a dynamic runtime language that's asynchronous. And I think V8 will still find it hard to work with try-catch. It de-optimizes your function when you use it. So I wish they could come up with a better way, but there was also new formatting numeric output and a couple of other enhancements, but it wasn't a major amount. The EcmaScript 2 was actually pretty powerful as it was. In 2000, Netscape 6 is released, Netscape 5, and it is not good. Basically, because they released the source code, when everyone saw the source code, they were like, "This is crap. We're going to rewrite it," which is actually kind of a typical developer reaction. It really doesn't matter how good the source code is of a thing. When you see it, you go, "This is crap. I should rewrite it." But so they were very much in an immature stage when they released Netscape 6. It was backwards, and they released it because they were under pressure. Because Microsoft had released IE 5, that supported ES3, and they were just about to release IE 6. So they rushed this out the door, the open source community, and it pretty much flopped. 2001, IE 6 is released, and it still supports just ES3. No changes. JavaScript innovation from here on out is pretty much done for a good long time. As is browser innovation for a while. Netscape market share goes down to 9% in 2001 and peters out to nothing by 2004. Because people just migrated to IE 6 had won the war, basically. 2002, this guy, I'm sure plenty of people recognize this guy, launches JSON.org. And that facilitates the rise of Ajax because it defines a format that's so simple that can be easily implemented in every language. And it's perfect for JavaScript because it's essentially a subset of JavaScript objects. You can just copy and paste some JSON and then make it into an object. It's really nice. It took 11 years, 2013, before JSON actually became a standard. When he first released it in 2002, the XML peoples, which was most peoples back then, were like really tribal about it, and they were like, "Why are you trying to ruin our way of life?" You know, if they were a country, they would have started bombing them and stealing their oil and things. But in 2013, it was standardized, and it was called ECMA 404. As in the spec that should have been there the whole time. In 2002, I was about 17, and for various reasons, mainly to do with not having enough money, I didn't have any internet for like a couple of years. And I had a computer, I got a Linux computer, and I had a Linux magazine, I learned Linux, which was nice, and I didn't have the internet to distract me, so I got kind of deep into that kind of side of things. But interestingly enough, I was pretty much offline most of the time between 2002 and 2007. And in that period of time, there was hardly anything that happened with JavaScript. That's why I think I'm like the messiah of JavaScript. No, the Russell Brand of JavaScript. No, it is interesting that like I didn't miss anything in that space. So around 2007, maybe 2006 a little bit for me, I started making websites voluntarily. And it used PHP. I used PHP to build these websites. At that point, I worked at McDonald's, and I started working in a homeless hospital, just moved over to Northern Ireland. In that year as well, the EcmaScript 4 white paper was launched, and it was not well received. There was lots of politics and grandstanding, lots of different opinions and directions. It wasn't well thought out. It didn't understand the nature of JavaScript. It was written by, generally seemed to be written by people who wanted to take it into the classical Java-esque direction, and it would lose that rich heritage from scheme itself, and the power of functions and all that kind of stuff. It wasn't an evolution of the language, it was a complete reimagining. And the thing that made it stupid was that it would break the web completely. So in 2008, this guy releases this book and really helps the industry by doing that. Has anyone read this book? Yeah. Has anyone not read this book? Who does JavaScript? It's worth a read. It's worth a read because it's so small, and pretty much everything you need to know is like in the book. You don't have to agree with everything he says, but it at least gives you kind of a thing to work around. You probably don't need to read it, Mars, but Mars is a genius, by the way, everyone. In 2008 as well, Google launched Chrome. And the significant thing about this, well, there are a couple of significant things, in that they become a major challenger to IE. Firefox was kind of challenging them, but they were really the underdog. When Google got involved, they became a big contender. But one of the reasons they became such a contender was their JavaScript engine, V8. V8 was a performance revolution, because JavaScript does so much stuff for you. It's very high level and it's dynamic. So a naive implementation was always going to be slow. But a bunch of really smart guys got together and they wrote a highly optimized VM for JavaScript. And when they did that, they proved that JavaScript can be useful, grown-up, production-level language. In that year as well, TC39, the technical committee, moves in a new direction. They go with, so EcmaScript 4, there's people trying to do EcmaScript 4, and then a part of the TC39 was like, yeah, we're just going to do 3.1 and just very slightly extend the language instead of completely reinventing it. They were making a point by calling it 3.1. It's like we shouldn't be like completely changing this. We should be extending it gently. These guys were catalysts to making that happen. Doug Crockford and Brendan Ike, and they both, mainly Brendan, actually led out that shift in thinking. And that shift towards like, let's recognize the language for the power that it has and build on that. at the same time, they introduced ES Next, which was ES6. And a lot of that was actually political as well, because the ES4 people, diehards, they were basically able to placate them by it wasn't called ES6 back then, but they were like, after we do 3.1, the next one, we're going to like incorporate some of the ideas and kind of it gives us more time to think about that. So in a way, ES6 actually does come from ES4, but it's been adapted to the point that it doesn't break everything. And also, hopefully, mostly recognizes a lot of the original power of JavaScript and the prototypal nature, but not everything. In 2009, EcmaScript 3.1 becomes EcmaScript 5, and the final approval draft is released. Still a draft, though. 2009, Ryan Dahl creates Node.js. And this really added to the momentum of JS innovation, both in the language and in applications of JavaScript. Like, what else can we do with it? If I can do it on the server side, can I embed it in hardware? So on and so forth. So it really opened up a lot of ideas, a lot of innovation, and that increased interest in JavaScript helped to fuel the standardization process as well, and move that forward. So it's a really great thing for JavaScript. In the same year, Firefox 3.5 is released, and the other Firefoxes were okay, but it was significant in 3.5 because it came with SpiderMonkey, and SpiderMonkey was basically comparable to VA as a performant JavaScript engine. 2009 as well, Chris Williams organizes the first JSConf. You may know him as Voodoo Tiki God. This is significant because the community interest, again, helps to drive innovation, and innovation helps to drive community interest. So this is starting to create positive cycles. Chris Williams, in the same year, also writes Node serial port, and that triggers the beginning of the rise of JavaScript robots. He's a really productive guy. He, whilst he's doing all of this stuff, he runs like a flower shop year-round as well. He's kind of a random guy. In 2011, EcmaScript 5.1 is the final standard of EcmaScript 5, fixes a couple of bugs, and gets released. And with it we have strict mode. Everyone know about strict mode by now, I'm sure. It basically, you put a string literal saying strict mode, and it changes your behavior a little bit, making it so that you can't do things like create implicit globals, you can't use with. Eval works differently because it can't create variables outside of the scope of the eval. We get some nice functional methods on the array objects, some nice stuff on objects. The object constructor that allow you to do things like freeze the object, creating immutable objects and so forth. String gets trim. That kind of should have been there a long time ago. When I read that, I was like, oh, I thought trim was always there, but it's not. So if you ever have to support an on ES5 browser, you actually do have to polyfill trim if you're using it. And then function bind comes along as well. If you're using function bind a lot, you might want to rethink that because it's actually kind of an expensive thing to do. And also, Douglas Crockford was on the committee, and there's no way that ES5 wasn't going to get a JSON native parser, right? So JSON, we get the native JSON object as well that gives us parsing and stringify capabilities. In 25, Chris Williams, again, creates the unofficial JS logo. I'm sure you've all seen this logo before. It's not like an official logo. One thing that he says about it is he says, it's not a JavaScript logo, because that would be a trademark infringement. It's a JS logo. But this becomes the basis of a lot of many things that are written on JavaScript, like Node bots and stuff. They tend to use this kind of branding theme. Johnny 5, for instance. In the same year, shameless plug becomes a fairly common idiom. And a guy called David Mark Clements writes Node Cookbook. I was working in a homeless hostel while I wrote this, and we had 12-hour shifts, starting at 8 p.m. finishing at 8 a.m. And as long as everyone wasn't going nuts that night and there wasn't like a lot of drug and alcohol-fueled activity, I would have a couple of hours of quietness where I could kind of really go deep and not be disturbed by anyone and write this thing. Fun times. So in 2013, Node reaches version 0.8. And early adopters in the enterprise begin to use it in production. In 2014, Node reaches 0.10, and it's good, stable, all-round improvements, not difficult to upgrade from 0.8 to 0.10, not really any significant breaking changes. I have to update Node Cookbook in 2010 as well, because things have moved so fast. When it got published, it was out of date, pretty much. The day it was published, I was like, right, something's just been released and now it's out of date. Since then, it's slowed down a little bit, and it's still kind of relevant, but now with all these IO.js developments and so on, I'm probably going to have to update it again in maybe 6 months' time. At the end of, what year is it now, 2014, the end of last year, is the IO.js fork. Everyone been following the story of IO.js? Not just some, but not others. So IO.js was a fork of Node due to developer discontent, essentially. The stewards of Node joined were seen as being inhibitive to the project. For instance, there would be pull requests and issues, and they would just not be dealt with for months on end. The 0.10 had been around for too long in the minds of developers, and 0.12 should have been here by now, and nothing was happening. And so it led to some of the core developers spinning off a project. What they actually did initially was they created a repo, a private GitHub repo called Node Forward, as in like, let's work on the next version of Node. But Joint went and said to them, that's a trademark infringement. We have to protect our trademark. Node is our trademark. Which led to it being called IO.js, which actually is a way more awesome name than Node. But we're gonna end up sticking with Node because of reasons, right? Like, I wrote Node Cookbook, I didn't write IO.js Cookbook, so it would be bad for me for a start. And that's just a small piece of the whole thing, very, very small piece. The enterprise is bought into the Node brand.
If they put the names together, it would be Nodio.
Node.io, yeah.
Nodio.
Nodio.
Like a rodeo.
Yes, like a rodeo.
Instead of a conference, you'd have a rodeo, so it'd be Nodio
The
rodeo.
Nodio rodeo, yeah. This ain't my first Nodio, bub. So, in 2015, quite recently, is the Node Foundation was put together, and an agreement between IO.js and Node came about for them to merge. So we've actually had the best ending to that story. If you look at other communities where stuff like this has happened, people have lawyered up, spent lots of money on lawyers and things, and lots of bitchiness and stuff. In this case, it was really handled with maturity, and I'm really pleased to see that they're actually going to start feeding in. So in 2015 as well, Node 0.12 was released. More because of the pressure of IO.js that caused it to be released. I would still personally be a little bit skeptical of 0.12. I'm still using 0.10 in production. But if I was looking at doing something progressive, I would use IO.js. Like, IO.js isn't just adding features, like upgrading to the latest V8, so you have some ES6 features. It's also doing things like, there was a new release today, I think, either today or yesterday, and they've reduced the amount of syscalls that are required called makes, which will improve initialization performance when you have lots and lots of requires. So they're doing some really nice stuff in the areas of optimization as well. And now that we have proper foundations, I initially didn't have much confidence about IO.js for the future, because I was a little bit unsure about whether it would end off going in a different direction, or start reducing the quality of the code and things like that. But it really does look like they're doing a great job. And it seems like what they're going to probably do is actually just feed their innovation into Node, and then Node will be like the enterprise product. They're also going to, part of the documents of the foundation define a long-term release strategy as well. So at the minute, I think 0.10 would be considered LTS. I might be wrong about that. So they'll actually have something they're going to support for several years for enterprise, and then they're going to have all the innovation for the new stuff. Let's look for 2015 at the landscape of JavaScript. I have two slides for this. Now this is just through my lens. I probably missed a bunch of stuff. If you think of anything, let me know, because I want to kind of maintain these diagrams. These diagrams were produced with something called Mermaid.js. As I said, this is the presentation system that I've written uses Markdown, and Mermaid.js is kind of like a Markdown-like format for creating diagrams. So we have V8, which led to Chromium and Chrome, and is also the engine of Node. And then Node forked into I.O. And Chromium and I.O. Are the basis of NW.js and Electron. Has anyone heard of NW.js and Electron? So again, this presentation system is built with NW.js, and it's the combination of the Chrome and I.O. or Node, if you like, environment. So it allows you to create like desktop applications using HTML, CSS, JavaScript, and Node APIs. Electron's the same, but they have like the way that they embed them together is like the opposite. I can't remember all the details, but they have a different kind of way about it. Electron is the basis of the Atom editor by GitHub. I think Facebook have just released like an IDE written in Atom as well, whereas NW.js is developed by Intel. Node serial port, which I mentioned, was a native module written by Chris Williams, has opened up by this year, has opened up so many possibilities to do with robotics and automation. There's a project called Cylon.js, which is a really, really nice community project that tries to create like a standard way of dealing with lots and lots of different robotic devices. And they have a module for everything. What they do is they try and find someone who's already written a module that interfaces with a certain thing, and then they build their own kind of standardized way of dealing with robotics around that module. Also, 2014, 2015 saw the rise of Nodecopter events, where you get like quadricopter and you can program it to do stuff. I don't know if you've ever heard of Substack, but one of the things he did with it, more so in 2014, was it 2013 even, was he would take a red rag, and the quadricopter would charge at the rag and he'd pull it out of the way. It was like, kind of a cool thing to do with it. And this just has generally led to the rise of Node robotics, but in the way that you communicate to them over a serial port, or over Bluetooth or Wi-Fi. It's all pretty much amounts to the same kind of deal. It starts with a serial port. But what also has fed into the robotics movement is the Tessel. Have you heard of the Tessel? So the Tessel doesn't implement V8. It's actually has its own runtime environment called T1 runtime, and T1 runtime is Node compatible. So you can put Node modules on the Tessel. So this is nice because it gives you this kind of unified approach to, you can just write it like you write server-side code. The Esprino as well has its own, which is another, sorry I should mention, the Tessel is kind of like an Arduino kind of deal, but it runs JavaScript. It also now supports Python and Lua, I think. Esprino is like a much lower capacity device with not a great JavaScript runtime, to be honest. And then finally, V8 feeds into Runtime.js. Has anyone heard of Runtime.js? Really exciting project. Runtime.js, the goal of it is to create a kernel that runs on bare metal. So the kernel will be implemented, well, apologies, the kernel, the very, very low level stuff will be implemented in C++ that communicates with the hardware, but then the stuff around that, like the network stack and all that kind of stuff, is implemented in JavaScript. So you have like fully asynchronous operating system. Every all of the input and output of the operating system will operate in an asynchronous fashion, whereas current systems that we have, a lot of the APIs that are at a low level are actually synchronous. So it could be really interesting. It also has some stuff to do with isolating context and sandboxing things in a really nice way. It's very, very early days, but that could lead to some really cool embedded hardware stuff as well, and even operating systems. Take a look at Runtime.js, really interesting project. We also have, not to leave out the Microsoft world, we have Chakra, which is the JavaScript engine for IE, and also the JavaScript engine for Edge, which is going to be a completely new, amazing browser because it has a new name. And the Windows apps also use the Chakra JavaScript engine. The SpiderMonkey JavaScript engine obviously fuels Firefox, and also Firefox OS, which is like a mobile operating system, so you can run all your JavaScript in mobile. It also feeds into GJS. I bet you've not heard of GJS. It's the JavaScript engine for GNOME. So a lot of GNOME is actually written in JavaScript. Didn't know that, did you? And then there's something called JX Core. Ever heard of that? JX Core is a Node-compatible project that uses SpiderMonkey. Whereas Node's goal is mainly to be for network server-side applications, JX Core's goal is again to be for like embedded hardware and mobile apps and things like that. But then you can write them with a Node API, any of the Node modules and so forth. Both Chakra and SpiderMonkey originally did this, support the use ASM mode. ASM is like an assembly form of JavaScript. It's like a subset of JavaScript that's highly performant. You tend not to write this yourself. There's a program called EcmaScript, which will compile a C program or a C++ program into JavaScript. It does that in a very kind of raw way. Doesn't really use closures a lot and things like that. So what they did to support that and really be able to like optimize for it is you have a function and you put a string at the top, just like you have use strict, you have use ASM. And then everything in that function, the JavaScript engine will flip into a highly optimized mode that ignores a large amount of the language and just focuses on this subset. V8 don't support use ASM because they have a different kind of thinking around it, and they're like, well, we're not going to support it as a thing, but we are going to optimize very heavily for it. So with V8, if you don't have the use ASM thing, or if you do, it doesn't make any difference. It will run as fast as it can run. So there's actually game engines, modern game engines, that have been compiled to ASM and they run at 60 FPS in the browser on an average level machine. So it's kind of proven that you can write really performant code with JavaScript as long as you're generating it with something else. And this has led to a really, really exciting development that was announced like 4 days ago by Brendan Ike, which is WebAssembly. Has anyone heard of this yet? And this is really, really cool because it's going to be a binary format for the web, which is going to be cross-compatible with ASM. So you can polyfill it with ASM.js. And the thing about ASM.js is like, even if the browser doesn't support ASM, it's a subset of JavaScript. So even if it's an old browser, it would still probably run. Probably not very quickly, but it would run. So you have this path where you can go right into this binary format. A comparison to this would be if you're back in the olden days when you're like a C programmer and or a C++ programmer, you're just not getting what you want from the language, and you can drop down into assembly code and actually edit the assembly code. And we're going to actually be able to do this with JavaScript. We're going to be able to use the high-level, powerful features of the language until we're like, no, right now I need to go into something lower level, and we can access that using WebAssembly. The other thing, of course, is that you're going to be able to compile any language to this WebAssembly format. So the same way that you can compile C++ programs to ASM.js, you can be able to do that for anything. You could also put anything into ASM.js as well. So this is going to really open things up for a lot of people. And all of this is going to lead to even higher performance in the browser, so I'm excited about that. 2015 as well, ES6 was renamed to ES 2015, so I guess that makes ES7 ES 2016. Okay, but so the thinking behind that is that basically they're like, okay, so if we don't meet the deadline, we're just going to release what we have, and anything that's not complete, we're not going to release. So that will go into the next ES8 or the ES 2018, ES 2019, and so forth. Whether they do that, I guess we'll see. ES 2015 was approved on the 17th, which was what, 8 days ago? 25 minus 8, 17? Yeah. So, like, this is fresh stuff right here. So, a lot of browsers, and especially IO.js, they have already implemented quite a lot of ES6. SpiderMonkey especially has most of ES6 implemented. But in terms of developing in ES6, ES5 was pretty easy because you could polyfill most of it. You could just jam something on an array prototype and make all the browsers work. ES6 has syntax extensions. So you can't just write ES6 code and think it'll be fine. So you have to transpile it, which is just a fancy way of saying compiling from one version to another of the language. And you're going to probably need to do that for Node modules as well, because you might have people using Node 10, so they're going to want to be able to use your module. So that's going to be a thing. What about the future? Well, the future for me is Soylent. Because, has anyone heard of Soylent? Yeah, it's an interesting project. I have a month's worth coming in soon, it's on its way. And I'm going to lose weight, I'm going to feel healthier, and I'm going to look like this. That's the future me, right there. I would also have to shave off all my body hair and get some underwear that goes above my trousers, and get one of those, what is that, like a thing around my neck. In EcmaScript 6, then, there's still implementing to be done. Chrome, Firefox, and IO.js are pretty much the latest kind of support. As I said, we've got transpilers. ES6 brings us let and const, which is block scoping. So you're probably going to see some new styles of JavaScript coming out. Whether or not they're good or not, I don't know. They may initially add more confusion for people, actually. Because they'll see a let and they'll see a var, and then they might use a var where they need to use a let, and then they'll have a function that returns the current value of a variable instead of the value that they thought it was in the loop, and all that kind of stuff. Promises and generators. Anyone know generators? Oh yeah, generators are really cool. Talk about that in a minute. EcmaScript 6 also brings us classes, which I'm not sure I'm actually totally on board with. Again, having this prototypal nature and everything, and emphasizing that would have been nice. We already have new, which has kind of confused people. This might confuse me even more if they come into the language and go, oh, it has classes. It doesn't have classes really. It has a class-like syntax that basically resolves down to prototypal inheritance. So, like, is that the best thing? I don't know. It will help with adoption for people from other languages. It also has modules, and again, I'm not that happy with the outcome of that, but what can you do? I feel that the module system in Node, CommonJS, is so simple and so nice, and then they've gone and done this thing where you have to like import thingy as thingy, and then you have to you have to export a default thing instead of just exporting a thing. If I export foo, when I import the module, I have to import the module, and then I have to look up the property foo on the module imported. If I want to export just foo, then I have to export foo and say it's the default thing instead of being a property. This is much more complicated to me than just like saying module exports equals function and require a file. The advantage, of modules though is static analysis. There's a great article by Dr. Axel Rauschmeier on Tuality, his website, about the advantage of static analysis with modules. But if that's all there is to it, then I'm probably not going to use them that much myself. Although I'm open to changing my mind. We also have the spread operator and the rest operator. We have destructuring, lambdas, so you have the fat arrows lambdas, which will also be interesting because now, along with people not naming their functions, you're now not going to be able to name your functions because lambdas are not named. So I'm wondering how that's going to work out with debugging. Let me just show you real quick the deal with generators. So to get this effect, by the way, I'm using some of the similar technology that Chrome uses to do Chromecasting, and I'm broadcasting that window into a video element on the presentation, which is really cool. So a generator is basically a function, but it has a star in it, like this. And you can return from these just like you can with functions, but you can also yield from them. So I can yield one, yield foo, return a. Sorry, I put the star in the wrong place. So then, when I call that function, it gives me an iterator. And the iterator has a property called next. And that allows me to step through that function. So I can control the flow of the function externally. So when I call next, it gives me an object with a value of 1 and done false. So because the first value I yield is 1. The second time I call it, the value will be foo, done will be false. And then the last one, the value is hey, because that's what I return, and it'll say done is true. Okay, so why is that awesome? Well, basically, because you can control the function externally, you can do asynchronous things externally, which means you can hook up an environment where you can yield asynchronous operations from inside your generator, and then not take the next step until that asynchronous operation completes, which allows you to write asynchronous code in a synchronous style. And a framework that's done that, has been doing it for some time, is called Code, C-O. So if I get a browser window up here and just show you very quickly. So this is Code. It was originally by T.J. Holloway-Chuck. You heard of him? The guy that wrote Express and about a million other things before he was like, no, it sucks, and went off and did Go. No, he's really good. I love the stuff that he's worked on. So with Code, you have this CO function. And you basically yield promises from it. And then the result of that function is a promise that gives you the final value that you return from it. So what's really nice about this is it allows you to, it gives you like a construct for doing parallel operations without having callbacks all over the place. So I have 3 promises, and I can yield them in an array. And when I yield an array, it runs those 3 promises in parallel. Or I can yield one promise on its own and then yield another 2 in parallel, and so on and so forth. So this gives me a really nice way to do this asynchronous stuff. Problems with this is like I said, if you're writing something with this sort of style, you're going to have to transpile it because ES6 and the star and yield are invalid syntax in ES5 and below. So that's okay, but generators, transpiling a generator is pretty bad at the minute, because the things that they have to do to make that work is very heavy lifting. Now that may or may not be a problem depending on what you're doing, because you could make the argument that even if the abstraction that controls the asynchronous flow is heavy, if it's not greater than your asynchronous operations, then it's not the bottleneck, and it doesn't matter. You got to weigh it up. So, yeah, really interesting, but something that I would consider using generators for is writing tests. I think they'd be really nice in writing tests, particularly if you have a lot of asynchronous things to do, because you could write them very cleanly. Although promises will pretty much give you the same kind of deal. In EcmaScript 7, possibly 2016, they're looking at implementing async await, which will pretty much do away with the whole thing about, you know, strong-arming generators into writing synchronous code. So we'll just throw all that away and we'll use async await. They're also looking at putting guards into the language. So a guard is basically a primitive that allows you to enforce arbitrary constraints on pieces of the language, and with those you could build your own typing primitives. So instead of enforcing types, this is really nice, I like this, because instead of forcing types onto the language, which is going to be like a split down the middle issue for many people, they're just going to say, here's the primitives that you can use to enforce your own types if you want to. Like it. And that approach plus that thing they're going to do in ES8, which I'll talk about in a second, is an approach at which they're taken from ES5. But ES7 as well, they're also going to look at event loop concurrency. So what we currently do with microservices is we have multiple event loops, and we pass messages between those event loops, right? In the browser, we would use something like a web worker to give us another event loop, and we pass messages between them. But what they're going to look at doing is a standardized way of sharing state between event loops. So that could be very interesting. They're not going to use the thread paradigm at all. They're going to do something different. In the future, ES8, they're looking at putting in macros, which is really nice. I like that because that kind of goes back to the days of Scheme. Because Scheme was a dialect of Lisp, right? And another dialect of Lisp was Common Lisp. And here's how they were different. Common Lisp was like throwing all the features, throwing all the things. Whereas Scheme was like, just make a really, really small thing and make it really easy extendable. So then you can just write macros that extend the language, and you build basically your own extension to Scheme for your thing that you want to do. If they'd have done macros prior to ES6, ES6 could have been built in macros, and a lot of the things that they wanted to put in, they may have like made optional, and like, okay, if you want it, just turn on this macro or whatever. And that would have been awesome, because something that I'm now concerned about is EcmaScript going to go in the direction where we just keep throwing features onto it, so that when someone comes to learn it, they're like, this language is infinite, and I'm just going to like learn a very small piece of it. And that's something that, you know, would have in the past prevented me from learning other languages, because I'd be like, oh man, like PHP for instance, it's like how far does this go? So there's like this line where a language becomes too big and it doesn't, once it passes that line, it might as well be infinite. But what JavaScript was really amazing at was you could master it in a fairly, maybe in a year and a half. You could get really good at it and learn and work with the subtleties of it. And I'd be concerned in the future that that's not going to be as easy to do. For people like us, we have an advantage because we already know it pretty well, and we're going to learn these new things, and we're like, yeah, I can use the stuff. But even at that, I'm probably not going to use all of it. I'm probably not going to use classes. I might play with them, but I'm probably not going to use them. So that's my rant. But another thing in ES8 is they're going to look at SIMD, single instruction, multiple data. So you can basically process arrays in parallel. And that will be like a really complementary thing to that whole idea of WebAssembly as well. So that's going to be really interesting. This is what I'm going to look like in the future. When we've all taken wearables too far. I've got my Google Glasses, I've got my Myo, I've got my heart rate monitor, what else have I got? I've got my Apple Watch, I've got my soylent injection system straight into the bloodstream. And I think that's the end of the talk, so thank you for your time and listening. Questions? Great, cool, okay. No, has anyone got anything before we wrap up?
What do you think about WebAssembly? Would it,
Sorry.
Hello, my name is Sergey. And what do you think about WebAssembly? Could it kill JavaScript? Because we just start to develop everything, let's say in Java or C# or whatever.
Right. I don't think it's. If it ever does, it's going to be a long time coming. WebAssembly is going to take a while to even get into the browsers, and probably maybe 5 years, 5-10 years, something like that. I don't think it's going to be the JavaScript killer, because there's plenty of power in JavaScript. What you're saying is that if you've got a stack written in Java, you'll be like, well, we'll just compile it and put it into the browser, and that's a lot about what that's for. But no, I don't think it's going to wipe out JavaScript by any means. I think there's plenty of room in the pool. But it will mean that you can pretty much choose the language that you prefer. And I would still choose JavaScript, and I would still bet on JavaScript myself. What do you think?
Thank you. I just also like JavaScript, but just starting to be afraid that in the future JavaScript goes out from the development, like Flash, when
Sure.
Apple just decided to not support the Flash.
Yeah.
It's go out 3 years, 4 years.
They killed it. That's it. By the way, Flash ActionScript 3 was essentially an implementation of ES4. So I'm kind of glad. But yeah, no, you have a good point, but we'll have to wait and see. It will be good anyway. The thing is that the extensions that they're making to the language at the minute with ES6 and stuff as well, it's probably going to make it not as contentious to not use JavaScript or not use JavaScript anyway. I don't know, there might be some reasons to use JavaScript, particularly for legacy as well, like older browsers. And you know what it's like with the browser world, you've got to support older browsers for a long time, although that is speeding up. And the other thing is server-side JavaScript. Like if it was just, if we only use JavaScript because of the browser, then Node wouldn't be popular. So there's value in JavaScript inherently, not just because of its positioning.
Well, let's see.
We'll see. Yeah. Anyone else?
What are your thoughts on TypeScript?
What are my thoughts on TypeScript? That's funny because I delivered this in. The question was, what are my thoughts on TypeScript? Which is funny because I delivered this in London 2 days ago, and I had exactly the same question. What are your thoughts on TypeScript? Look, I think that if you come from a C# background, TypeScript is really nice for you because there's a lot of similarities between it. If you have a Microsoft environment and you use Visual Studio and IntelliSense, TypeScript is nice for that. But the problem that they're solving, I mean, they've put a lot of effort into solving a problem that's not really a massive deal, which is the whole type safety thing. So essentially, TypeScript to me works a bit like a type linter with extra annotations. I've been using JavaScript since I was 12, and it's never really been a big deal. Like once or twice learning the language, maybe more than once or twice, I had a NaN because I wasn't checking for a number and things like that. But yeah, I don't think it needs to be solved in that way. And the other problem with TypeScript is its ecosystem. So to be able to benefit from the value of TypeScript, if you're using a library that's written in JavaScript, you need a DTS file. I think it's called a DTS file. And so say you use jQuery, you need a DTS file for jQuery to get the benefit from using the jQuery API. But the problem is, there's more than one version of jQuery, right? The way that the repository works for DTS is there's only ever one version in the repository. So you go and download, there's like a little command line thing that you can get that DTS file, and it might be the wrong version. And then you'll have errors, lint error, TypeScript errors, because it's the wrong version. So then you have to go and modify it yourself. So there is a problem with the ecosystem, I think. But some people have built on TypeScript, and hopefully they're feeding into the system. I wouldn't use it myself, but I do appreciate the value of it for certain people.
That's one because I noticed that the new version of Angular 2.0,
It's going to use TypeScript. Yes.
which indicated it's getting some traction.
Yeah. Yeah, no, you're right, I think about that. But, so the thing is, TypeScript is pretty much EcmaScript 6 with their extra type annotations. And what Angular was going to do was they were going to use EcmaScript 6 and have their own type safety system. And for what they're doing and the way that they want to do it, they obviously want to use type safety. And it might make implementation details easier for them at the end of the day as well. So the thing with TypeScript as well, hopefully by version 2 it will be mainly optional. So when you run that build, you don't have to have all of the type hints. So when you run that build process, it will just say, hey, you set this to a string, now you've changed it to a number. Did you really want to do that? And I think there's value in that. I think there's value in that, but not having a strict type system.
Thank you.
That's, when you're building like enterprise client-side JavaScript apps, would you say Angular's a good choice, or?
I like Angular. I think Angular's a great choice, but it does depend on your project. So just in case anyone didn't hear that, is Angular a good choice for JavaScript enterprise applications? And really depends on the size of the project and developer experience and what people believe that the experience would be of developers going forward. One of the main selling points of Ember to a lot of companies is that everything that you do with it, your processes and the way that you work with it, is predetermined. So you can jump from one Ember project to another and they all look the same, which is really nice. With Angular, you don't get that. With Angular, you basically have to figure out how are we going to put this together. But it's been around for a while now that there's some good practices on how to do that. You can research and find out the good practices. Yes, that's a little bit more work. The thing that put me off Ember in the first place was the way that it worked with objects. You had to like call get and set methods and stuff like that. I haven't looked at Ember for a while, but I don't believe you have to do that anymore. I think you can just work with objects directly. So that kind of makes it a stronger contender as well.
Can I jump in there?
Yes, you're like the Ember dude, aren't you?
Yeah, so I'm part of my work here at Intercom, and we're heavy Ember users, so like we've got probably 35 developers working in an Ember code base, and we looked at Angular, but we didn't like that it didn't have those strong conventions. So that's why for us Ember makes total sense, because we hire these new people and even several projects, different teams, we all know exactly how the code base works.
Right.
And you're saying about get and set.
Right.
They've recently dropped support for IE8, so that's going to be on the way.
I
So
see.
So that's going to be Ember 2 or whenever we eventually drop that. But for large teams, I definitely recommend Ember, and I guess even the wider ecosystem.
Yeah.
Because like with build tools and kind of you have React, and that kind of solves the view part, whereas Ember has, I guess, like back button, routing, all this sort of stuff. So yeah, that's.
So I would be interested as well to see again with Angular 2 whether they're going to actually introduce stronger conventions or not. And it's a double-edged sword though, because if you do have those strong conventions, you don't have the flexibility necessarily to do things that you might be looking to do. I built a project in Angular, but I wasn't working with a team. I was working just as a freelance developer on doing a single project. And when I chose Angular over Ember for those reasons, that I can actually work with it the way I want to work with it, and I have more scope. And it was a successful project, but all of the knowledge for that project is in my head. So he rings me up every now and again. React is another, you brought up React there, is another contender, and there's a large company in New York that was using Ember and has now moved over to React and they maintain hundreds of websites. I haven't looked at React enough to know what made them make that choice.
I think it was mainly performance.
Right.
Because Ember traditionally does have a problem with massive lists.
Right.
And they've actually re-implemented the view layer, and now it's actually using kind of DOM diffing, which React made famous.
Right, so it's the same
So they're
kind of
actually, yeah, so they've redone it with that. So it's not even there yet, it's in beta, it should be coming like the next 2 months or something like that.
Lovely.
So React is mainly the view layer, and it doesn't kind of talk about how your data kind of flows around the whole app. And people have talked about Flux. So Flux is basically an idea, but all these different people have implemented different ways of doing Flux, and there's all these different competing standards. But Ember tells you how does data flow through your app. So we don't need to discuss this. We don't need to have a fight shed about all this sort of stuff. It's already there.
Yeah. Another thing that I heard a rumor about, but I haven't verified it, is they may be looking at extending, hopefully not the JavaScript language, hopefully the browser environment, so that it actually acts like an Angular or an Ember, or it has this data binding and it has the reactive kind of elements to it. They better not put that in EcmaScript, because then I might move to another language, because that's just a stupid thing to do. But it would be interesting to see how the newer features like Object Observe, I don't know if you've heard of Object Observe, that would really feed into this whole area. So, Ember might be better for teams.
Can I ask a question then on Ember? So when you're developing, when you're part of a team developing Ember applications, how much of your time do you spend writing pure JavaScript code as opposed to Ember specific code, if you like?
Well, it is Ember, or it is JavaScript.
Yeah.
Recently we undertook a massive project where we've written basically an editor in JavaScript, but most of that is just written in pure JavaScript, because we couldn't use Ember. We use Ember to give us all the eventing of when stuff happens, but most of it, all the DOM stuff, and you can drop. So it gives you all these release valves that you have to follow all these conventions, but if you need to break out of it, you can. So you can pull in any, if you want jQuery plugins, and just wrap them, to kind of make them work with the Ember environment or something like that. But generally, you're just writing JavaScript. So they've aligned themselves heavily with ES6. They're the first major library to bring transpilation of ES6 modules. So we've been writing ES6 modules for a year and a half now. So Yehuda Katz and Stephen Penn are there on TC39. So they align themselves with TC39 and even stuff like components. So yeah, it's still JavaScript, but obviously it's opinionated. But I think it works for us.
Anyone else? Cool.
Pizza?
Pizza, yeah. Yeah. Can we eat the pizza now?